Well, good afternoon, ladies and gentlemen. We've got of the three scheduled talks, the third talk by Antonio Leoy, unfortunately, cannot be given because Antonio had some staffing difficulties and therefore didn't have the manpower to send here. But what we're going to do is allow the first two speakers to have as much time as they want. So if they want to run over, that's fine. But then it just so happens I've got a talk about the third A of AAA. We've not heard anything about the third A. And in fact, in the talk before coffee, Ken Klingenstein said the third A had been forgotten about. Well, I've got news. It hasn't been forgotten about, and we've actually are in the middle of building a secure audit web service. So we'll say a little bit about that, whatever time we get at the end. Okay, fine. So first of all, our first talker will be Diego, who's going to talk about an architecture for GEANT 2, for the first two A's. But after you see my talk, you might want to fit the third A in there somewhere. Okay, thank you very much, Diego.
So now it's not mute anymore, right? Okay. Thank you. So, well, thank you, David. Well, good afternoon to everybody. Well, I'm going to show you what when we decided to send this to the GEANT 2 track in this conference. It was first steps. I would say that during that period we have made. Well, a couple of steps more, so this is going to be a little bit more detailed than it was originally when we conceived the paper. That, as you can see there, it's not only made by me, but also by Herr Rosenbach and Menier. Bierenge is not here? No, not yet. So, who are also very heavily participating in all this definition of the GEANT 2 AAA. Well. What is the GEANT 2 AAA? It's something that we for sure have to look for a nicer name, because GEANT 2 AAA is nothing to do if we want to compete with names like Shibboleth or Permis or something like that, because it's not so appealing. We have to find something, and that's something we find. I hope we will find it soon. But for the moment, let's call it. It's a result of the GRE 5. Of GEANT 2, the Joint Research Activity 5, which is officially named Roaming and Authorization. And, well, as it's stated there, it intends to be one of the basic services of the coming Pan-European Academic Network. For this time, and it's, I think, always I have the opportunity to say it, I do. For this time, the GEANT process or the evolution of the European network has taken into account not only the network infrastructure itself, but also what has become already basic infrastructure, as security, as monitoring, as the case of the AAI. So the idea is that this AAI it's a common service to all the services provided by the network, and that means. For example, for network access itself, the idea is to use this AAI to decide if a user has rights, who this user is, and which rights has to access the network, and to request, for example, a premium IP service. This is something that has been planned very soon in the GEANT 2 deployment, or going a little bit further in the future to ask for bandwidth of the on-demand services or whatever other they appear, and of course, to all services. All the services based and provided on top of the network, like application. Essentially, as you can imagine, they are the web-based application and grids mainly. But we can think of some other things in the future. Well, the first steps of the GEANT 2 AAI definition has been gathering requirements. This was the first deliverable we provided to the Commission some time ago, And we decided to group it in several general categories regarding what the AAI, with goals the AAI should accomplish. In the security category, we include these three ones. We say reasonable security, because, well, we feel that just security was something too naked, and it is important that security is something that costs. That costs not only money, that costs time of the people who are maintaining it, that costs time for the user and hassles to the user. That the more secure a system is, the more cumbersome it used to be. So the idea is to balance between the need to ensure the secure access and the value of the resource you are pretending to protect. So the idea is that the AAI will be able to provide different levels of assurance in order to decide whether this is a very valuable resource. I want to protect it the most I can. So users have to engage in a long process to get to in, or there is a, well, not so valuable resource. It must be fairly open, so I can provide this in a more relaxed way. Of course, it has to comply with privacy regulations. The idea is to avoid any data leakage when performing the AI interactions. I was not able to be here during Ken Klingenstein's presentation, but it's something that I heard once from him, and I repeat very, very often, is that the problem with privacy is that it can only degrade. You can never enhance privacy when you have lost part of your privacy. So it is to avoid any leakage from the interaction, and provide users with the definitive control about which information about them is being released for accessing. And of course, accountability, which is something that's a requirement, as David said. And we're thinking about how it will be possible to trace back what has happened, why it has happened, where it has happened, and when it has happened, whatever it is, negative or positive. Well, more requirements. Of course, we want to make the infrastructure compliant with the standards and as open as possible. So what the idea is to make open and neutral. Do not mandate specific technologies at the edges, and this is important because we are going to integrate different existing systems in different parts of Europe. And of course, our idea is to use open standards to interconnect these elements. So everybody can plug either another internal element in the future, or can decide to plug an external element without any hassle, or well, any serious hassle, so to say. Standards are what they are actually. And of course, it's the idea of the AI is to offer an integrated platform. It's not, we don't pretend to be a substitute of existing infrastructure. There are very well established existing infrastructures in Europe right now. In the previous session, Michael Lindengang has been presenting the Hacker Federation. You've got in the UK, you've got Athens. In Spain, you've got PAPI. The Netherlands has a select in place. The Nordic country, Norway has FEIDE. So the idea is that we are not going to replace them, because it has cost a lot. The Switch AAI, now that I have look at Thomas also. The Switch AAI is also in place, and it has cost a lot of time to convince the user organization to establish the agreements to build this infrastructure. And for sure, I'm not going to tell my user institutions to forget about something I have been for the last 5 years telling them. Install this, install this, install this. And after 5 years, when I have 20–30% of them convinced and running the system, to tell you, throw away and start with this brand new thing. So the idea is that we will build a superstructure connecting all the 16 infrastructure right now in Europe. But on the other side, there are places in which this federation don't exist, and they would like to use, or they would like to use the system to build them. So the other requirement, which is a little bit, it's not so converse as it would looks like in the first at first glance, is to provide some other interfaces for those who want to use the GEANT to AAA directly. And the idea is also to provide direct AA services to those communities that, for some reason, and we are thinking mainly right now in grid, in the grid community, are using their own methods, but could benefit of the services offered by the GEANT to AAA. Well, operational requirements, of course, it has to be as much scalable as possible. It should be able to grow in any dimension. It's going to span the whole Europe. Initially, it's going to be built by the partners of the GRE5 activity, but it has to. We want at least total European domination, if not total global domination. It has to be able to grow functionally, offering new services that they are needed, and structurally, so it can allocate different levels of structure. If we are going to offer a brand new pan-European federation, we will need to be able to connect with the American Federation, with the federations in the Asia-Pacific area, etc. Should be very easy to use, because we are talking now to extend this must be extended to normal playing users, to people teaching philosophy or people teaching classical history, and they don't want just to have a web browser and writing a username and a password that they have in a post-it note, stick to the screens. It has to be robust, has to support high traffic, and we have designed it as a basic infrastructure, so it has to be able to support stress, and it has to be flexible, and the idea is to apply the basic principles of federated administration. So I am not going to go through them as they are. Well, from these requirements, we started in a phase in which we are now more or less finishing defining the architecture of the system. The architecture, I would say, is almost completed. We're still polishing the fine details. No, the finer details. So, but the idea is that the general idea of the architecture is what I'm going to show you in the rest of the slides. Are based in a set of internal components. Just basically there are two, which is what is called here in the slides a local AAA instance. So it has to be argued about the term local. So it's a federation AAA instance at each federation domain real, whatever you call it. At each point in which there is a community with a trust, a web of trust built. And the idea of this federation AAA instance is to provide the interface to the federations or services when accessing the common AAA, GEANT to AAA. And a set of common services that could be used by this local AAA instance to access, to obtain certain, we don't like the term central services, because it's something that this is a federation or federations, so we are not going to provide the central service, but a federated common service. The one we have defined so long is so far is the home location service, in which from which a resource which is intended to be accessed by a certain user can locate back where the users, the home domain, realm, federation of the users, without requesting too much information for the user. So without making the user to disclose personal data about her. Other possible. Well, we could think about a certificate verification common service in which you can establish the trust in a certain certificate using a certain sort of common repository based in OSCP or whatever other protocol, and common diagnostics to find and to make things accountable, as much accountable as we can. And these common services will be only available to the local AAA instance. So there will be internal, in the sense that the only interface to access them will be through the local instance. Well, this is the general idea. You can see here the general relationships among the different parts. There is a remote domain on the red side, which is there is a resource which is going to be accessed. On the left, the home domain, where there is some identity repository holding data about the user who is willing to access. The user even think that the user is not need to be a physical person. We are even talking, or could even talk about some application willing to do some calculation in some resource in the remote domain. Well, the remote domain is able to make to exchange or to make questions about authentication data through authentication and about authorization to ask for authorization decision to the global AAA through his local AAA instance. The local AAA instance, the remote one, is able to try to locate the home location of the requester through at the home location service, and both local AA instance can communicate to exchange attributes about the requesting user or data about its identity, authentication data. In the same sense, the local AA instance is in charge of requesting this authentication data or these attributes from the home domain to push the attributes or the data pertaining the requesting user. Well, apart from this internal components, what we have defined is a set of connector of interfaces where federations, individual components, or even what has been called legacy system or systems that have their own procedures can connect to the general interface, to the common GEANT to AAI. The connectors can be centralized, and then again the term centralized put into quotes because we have to be very much careful when talking about central and not central. They are centralized for a federation in the sense that are the only one for the whole federation. So think of a connector on top of the switch AAI, connecting all the transactions that the switch AAI needs to make with the global GEANT to AAI, passing through this connector, through this interface, okay? Which we have called the local federation connector. Some federation might decide to go for a more peer-to-peer model in which certain resources and certain identity repositories could exchange once a trust link is established between them, can decide to exchange directly information without passing through the local federation connector. In that case, the local federation connector is only providing the initial trust link among the initial and dynamic trust link between the requester, the resource, and the identity repository. And in the case that there is no federation in place, or that federation has some internal procedures that are not exactly fit to this architecture, we propose the creation of what we call service access points. The idea is that this service access point will be in charge of adapt the AAI interfaces to service AA, any service AA query or response regarding the identity, attributes, and rights for a certain user. Well, that can be the general idea of a local federation connector. You can see here on top in green there are the common GEANT to AAI interface on the local side and on the remote side. So whenever a resource is going to be, and you've got here the federation limits. So inside that could be any federation you can think of. It's a switch AAI, the PAPI, FEIDE, whatever. Whenever a resource is going to be accessed there, the access management procedures in general, the authorization procedure, have to decide where to go for requesting information about the user who is making the access. And for that purpose, they contact the federation service. It could be a wave in the case of Shibboleth. It could be a GPOA in the case of PAPI, for example. And this federation service these federation services are going to redirect requests either back inside the federation to some other site in the federation, so nothing happens with the GEANT to AAA, or you have to slightly change the federation common services to be aware of the local federation connector. And in case there is a request that is to be satisfied outside the federation limits, this request is going to be satisfied through the local federation connector that takes care of making contact using the GEANT to AAA interfaces in the local, for the local service for locating the home domain, and in the remote interfaces for locating the remote domain. Okay? In the case of local connectors, which is, if you look at this diagram, is very similar to the other one, the only thing that changes is that the local federation connector can enable a local connector on top of the site to access directly the remote interface once a search and trust token has been passed to the local connector. This way we follow a more flexible approach, so in some cases you avoid the single points of failure, and you avoid the to clutch a central system. On the other side, you are risking here a certain lack of control over what happens out of your federation. So what we want to do is to leave each NREN, each federation, each community the freedom to choose whether they want a very much centralized system or they want something a little bit more peer-to-peer. Time will tell us which of these models is more popular, and maybe that in the future we go for this or for the other one, depending on that. Some of them are not going to be used, but the architecture is going to be to support both. In the case of the service access point, there is a realm, whatever it is, controlling a certain set of resources, and this realm can, of course, have some specific agreements, whatever they are, with some other realms in the system. Here is no federation concept here. So the idea is that the realm is able to ask the local AA instance for authentication data, ask for authorization decision if it wish, and of course using the results coming from the local AA instance about the remote part of the connection, can also check data or request attributes or request authentication data to the remote interface once established, which it is. Take into account that the only thing we are requesting here for the service access point is that they have to speak green. They have to speak in the using the protocols and the profiles we are defining now in this phase. Is the only requirement. Apart from that, inside the service access point, there's some other decision, calculation, whatever can be made. For example, things of a grid resource can be calculating whether there are enough computing power as requested, or a bandwidth allocation system can be calculating whether it can or not can be possible to allocate the requested bandwidth in that moment. Well, the characteristics of the architecture in what respect to interface and operations it's based on web services, and it's going to be based in SAML 1.1 for the moment. Maybe that in the future we make evolve this to SAML 2.0. And there is already a WSDL definition of the operations at the ports of the complete at each interface. We will make as shibboleth compatible as possible. We know that shibboleth is what it is. So our idea is that in the part that this system is going to it will be able to exchange that data with a shibboleth service provider or a shibboleth identity provider. The idea is that they will be fully shibboleth compatible. So a local AE instance and a shibboleth identity provider should be able to exchange data directly without any gateway or adapter or whatever. And we have identified, 4+1 pairs of basic interaction. The first one is just the access request that depends on when on which environment you are. The access request can be an HTTP request for a web page, can be a request for bandwidth at the service access point, can be a calculation request at the grid, whatever it is. So it's something that it is a little bit in a fuzzy state and will be in a fuzzy state forever because it's something that is out of our scope. But it's what initiates all the process. Apart from that, we have the defined authentication data request, authentication data response, home location request, home location response, attribute request, attribute response, authorization request, authorization response. We are now in the process of defining parameters, protocols, and profiles. As long as I can tell you, up to today, up to now, the parameters of the operation are, I would say, almost defined and agreed by the group. And we are in the process of identify which protocols and profiles for the first venture. For sure, it will be SAML. In any case, we can accommodate SAML interaction. But for example, for the home location, we have to so to say to invent our own protocol. Well, this is the idea in the big picture, which is the complicated picture in which you can see how all the interactions are going to pass through in a couple of established infrastructure with two federation connectors. This is taking all the interaction are taking the whole way they took in the worst case. This is the longer ways that the interaction will take using the local federation connector at each level. I leave it for you, for the curious reader that wants to have a look on the presentation, and you will have it in detail. And of course, if any doubt, comments, or whatever here or afterwards, will be much welcome. This is the time frame diagrams. When there are federation connectors, I show you, it's a little bit clearer. Thank you, David. It's not David here. Here, David Simonsen is not over here. Well, thank you to David Simonsen, who was the. Well, okay. It's on the webcast. So you can see here also, which is the flow of messages among the remote side, the home side, and the infrastructure components. Again, I left you for the curious readers. In the case there is a SAP, things are a little bit simple to see, but maybe a little bit more complicated to establish the trust links and all the like. But using the same operation, you can see that using the same architecture, we plan to give service to an isolated access point in some place in which there is no federation working, or there is a complete alien federation to this structure, to connect to a home location in which a user has identified him or herself inside the federation that belongs. These are this is also the time flow. You can see that the attribute requests go through the whole. They pass through the whole all the components directly to the SAP, so they are simpler. But at the SAP, you have to establish the trust. So it's a little bit tricky in what respect to that. Well, and just to finish is what we have ahead of us. So it's coming to a fine network connection near you. It's a full architectural definition, including protocol and profiles. It has to be delivered during this month. I hope we will fulfill the commitment. We are going to begin to work right now in a first interface implementation for SAPs. The idea is that some GEANT2 areas dealing with bandwidth allocation, bandwidth on demand, monitoring, they have heard of what we are doing, and they are willing to use our AAA services based on the SAP model, right, for the moment. So the idea is that we are going to build a first interface that would help us in making test cases for the whole architecture. We have in front of us the implementation of connectors and components. We plan to base it on something called R, which is an outcome of Terena task force. And well, if everything goes as we expect, I or some of my colleagues will be able to show you a demo of the GEANT to AAA at the next TNC, of course, the program committee permitting. So that's all. Thank you very much.
Okay, questions? I think particularly in the GGF, they've already specified an authorization profile for SAML. And at the next meeting, they're going to start to work on a more advanced profile. So they've done one for SAML 1.1, and they're now going to look at either SAML 2 or hexacamal. So it's sort of a question of liaison.
Well, not formally in the...
Yeah, sure. So the question was, have they done any liaison in terms of profile specification with other people who are working in this area, in particular the GGF, who've already specified a SAML authorization profile based on SAML 1.1 and is now working and interoperating, and in fact at the next GGF meeting they're going to be working on the next version of the authorization profile to add to add operational parameters and obligations, for example. So, you know, I'm wanting to know if there's going to be coordination between groups in the world who are working on the same thing, so we don't actually invent the wheel several times.
Well, we are trying not to invent the wheel several times, for sure. No, there is no, for the moment, no, there is no formal relationship between the GRA5 and some other groups making, in particular, this SAML. But we are trying to leverage the situation in which GRA5 is very much related to a task force in Terena, which is called TFEMC Square. So at the TFEMC Square, we have had a couple of presentations and discussion with the people working with the SAML grid profile and with the use of SACML, and so the group is aware of that. And well, I'm confident that there is no official liaison. There is nobody from the GGF group coming to the GRA5 meetings, and nobody from the GRA5 meetings, at least as GRA5 representative going to the GGF meetings. But there is knowledge. We're knowledgeable of the effort. So.
Well. Any more questions? Okay. Well, let's try this. As you can see, our next speaker is Kostas Kalivros from N2A Network in Greece, and he's going to be talking about using Radius as a backbone protocol for supporting AAA. Thank you, Kostas.
Thank you. Can you hear me? It's okay? All right. Now, my presentation won't take that long, so David will have his time. The presentation is mostly focused on using Radius and Pgina as an AAA backbone for Windows networks. No. What we have today is mostly that Windows are still dominating the end-user workstation. And in the central server market, there are always Windows Active Directory for supporting the Windows workstations, but and mostly there's Unix, Linux, FreeBSD, other flavors of Unix in general. Now, the authentication infrastructure for these services is twofold. The Windows workstations authenticate through Active Directory, and Unix usually authenticates through LDAP, although it may still be authenticating through text file passwords or through PAM. The problems faced in this procedure are that in the Windows part there are multiple domains, and users usually need to be present in all of these, so they need to be included and deleted when they no longer exist, and it's one of those. Users should exist in both the Active Directory and the LDAP server, so we have the same entry twice. and these need to be synchronized. And the last and most important problem is that passwords are not synchronized. And there are two ways to solve these problems. The one is using meta directory, which will connect the Active Directory and the LDAP servers and move along the changes from one point to the other. And the other solution is to replace the Windows authentication with our own. Now, what problems are faced in the meta directory solution? In our experience, it's not scalable. If you put in multiple domains, it will, for a few domains, it will go well. But if the domains go more than 5, 10, 15 separate domains, the process will not scale. All the protocols are closed. It's not LDAP per se. It's ADSI and things like that. The products are mostly closed. They come from IBM, from Sun. There's no open source solution. And the administration for and troubleshooting for this solution is quite complex and hard. Adding a new domain usually takes about half an hour of rather complex configurations. Now, in our case, we needed to be able to, we have the Greek school network, which has 5,000 domains. Each school has its own Active Directory server and its own domain. And there is a central LDAP service. What we needed is to get these two to communicate and synchronize the accounts. In our case, a major problem is the number of the domains. We had tested the Sun1 password synchronization service. And what we found out is that the server created a connector process for its domain. So that would not scale more than 20 or 30 domains. The deletes were a major problem to go through. The LDAP servers were receiving too much load. But I think there was around 10 LDAP searches every minute. So adding domains would create a major problem. And also there was the major overhead of adding and deleting domain and in general administrating the domains in the meta directory service. So after having a month of testing, we dropped that solution. The solution we came up with is Pidgina. It's already available. Its main idea is to replace the Windows authentication on its workstation with its own. And this has a lot of configurable modules underneath it. It supports LDAP, Redis, SQL, mainly for authentication. It can interact with a domain controller. That is, the account may be created on the domain controller based on attributes returned from the LDAP or from the Redis service or the SQL service. And also, account caching is supported, which means that when a user logs on, he will not log on through the module, but if the user exists in the Active Directory, the Active Directory will be queried before any module is queried. So that gives us a benefit in speed and does not put too much load on the Redis or the LDAP server. And that's the URL for the Pidgina project. What are the advantages of using a radio service? Well, mostly it's because the radio service is the decision point. It's not just a database. You can make complex decisions on that based on checks on the incoming packet and create a number of flows of decision points. There's a dynamic expansion and calculated values for the returned attributes, which can be expanded on its user or calculated for its user. One other major advantage is accounting, which allows you to see when a user logged on a specific workstation, how long he was logged on, and things like that. And that enables you to do things like quota management and only allow a user to sit in a PC for 4 hours. That's an idea we have for the students in our university, so that we don't allow them to sit on 10 available PCs all the time. It allows you to delegate your administration, since usually the user database is stored in a LDAP or SQL database. We have created an infrastructure for supporting anonymous users, which are created and are valid for only 1 day. And there are special features like user time quotas, what I mentioned before, login time restrictions, like a user can only log in on working hours from Monday to Friday and not anything else. There are default and group profiles, means that a professor may have more time quota than a normal student, and that can be done through a group profile. And there's also the default profile, so we don't have to add all the attributes in each user entry, but only those that will be different for that user. Now, what are the Redis problems? The Redis server is native, which creates another point of failure and needs a bit more administration than having only an LDAP database, for instance. And the most important problem is that the Redis secrets need to be stored in its workstation. The Redis model will take care of adding an access list so that nobody, apart from the administrator, can look at the server secret, but that still is an issue. Now, Redis versus LDAP. Well, what I said before, Redis is a decision point, while LDAP is mainly a database. There's no clever thinking in LDAP. So it's mostly a point of powerful versus simple. One problem is that Redis is an extra, as I said before. And another thing is that we can restrict LDAP access and not make the LDAP server visible to anyone but ourselves, and have the Redis server as the front end for the operations. Now, our team involvement was PGNA code patches from another person and a large part of the Redis plugin code. Our to-do list is mainly to add AAP TTLS support for password transmission, which will allow us to not have to deal with the Redis server secret being stored in the workstations, since the TTLS tunnel will take care of securely transmitting that information, along with anything else we might need. Now, in real-life usage, it's used in the NTUA library for 15 to 20 PCs, providing authentication to public or workstations. And it's scheduled to be used in the Greek school network. We'll see when that happens. I don't know when. The conclusions is that it is a viable solution for providing a framework for Windows AAA authentication, authorization, and accounting. And it's secure, it's scalable, and it's a powerful solution. That's it.
Okay. Any questions for our speaker? Yeah, sure.
Dubravko Penzic from Croatian
I'll
Academic.
come there later.
Sorry?
No, it's okay.
Dubravko Penzic from Croatian Academic and Research Network, University Computing Center in Zagreb. We use PGNA for our public terminal. I wonder when AAP TTLS support in Radius plugin will be available. Do you plan it to?
Well, my changes to the Redis model were mostly ad hoc because I needed them. So it's mostly depending on how much time I will have available.
6 months Year?
I
2
don't know.
years?
I think 6 months.
Okay, thank you.
Any more questions? Yes.
In your implementation, where is the radio server located? Is it a central server, or is it located at the institution?
It's located in the institution. It's a central radio service for the university.
Any more questions? Okay.
How do you plan to deploy this in the whole school network? I mean, right now you have a central service in the NTUA, right?
Yeah.
And which are your plans to deploy this in the?
Well, we'll have to update the workstations in the schools. That's
no, but I mean, with structure, would you plan to have a central
there's
radio server for the whole Greece? Several.
There's
a hierarchy.
already a radio service for the Greek school network, so we're going to use that one. Because of the account caching, the radio service will be mostly used only for user creation and user password updates. So the load won't be that much, and we'll probably not be needing accounting. So it's mostly small numbers.
So you don't plan to have an LDAP or SQL?
No,
backend?
we will have.
Yeah.
The authentication will be performed through an LDAP server. That's where the user accounts are. But we are not planning to use accounting since we don't need it that much in that case. In the NTUA, we're using accounting to provide a quota management, to only allow users to connect 4 hours per day, since it's a limited number of public workstations.
Any more questions? Okay, shall we thank our speaker? Thank you. I'm going to say Diego's going to chair me now. It's probably I chaired you, so you can chair me.
It's a pleasure to introduce you, Dr. David Chadwick.
This is a standing talk. It's actually a talk that I gave the other week at believe it or not, it was at an auditing, continuous auditing symposium. And we're building a secure audit web service for the TrustCom project and also for our own users. So I won't take you longer than the scheduled time. So what was the purpose of the login service? First of all, we want login for authorization decisions because we need to keep a record of who's been granted access, who's been denied access, because at some point in time you may want to go and look through the logs and find out was anybody trying to hack in, and who did manage to get in, was the policy the right policy, did it keep out the people we want to keep out, etc. So we wanted that. Also, there's a feature in authorization called retained ADI, which I'll show you a picture of at the moment. But the best example of this is when you go to an ATM machine and you put your card in and you say, I want €100. And it goes and trundles and it says, granted. You say, oh, that's very good. And you go in again, you say, I want €100. And it says, denied, because you've got a limit of €100 a day. And that is a function which is known as, in the ISO standards, retained ADI. The authorization infrastructure remembers what you've done previously, and it grants subsequent decisions are made based on previous decisions. So you have a state-based authorization engine. So if you're going to have a state-based authorization engine, then you need to have some secure way of logging everything and some way of recovering it if you fall over. And for recovery, you need to be able to recover what you've got. So that's another reason for wanting it. And then within the virtual organization, we want an audit function to record transactions and everything that's gone on within the virtual organization. So that's the rationale for producing it. So as I said, the retained ADI, this is the general diagram that you have for authorization decisions, where you've got your PEP and your PDP. And with retained ADI, then I'll quickly move on. With retained ADI, you have this information that's stored within the PDP, and it will make subsequent decisions based on not only who the requester is, what his request is, what the target is, what the policy is, and what the contextual information like time of day is, but also based on what's happened previously. So this is the functionality that a secure audit service will give us, because it will record that permanently in audit logs and allow us to recover it after startup and recovery. The TrustCom project, which is actually funding this, is a 6 framework integrated project, which is providing trust and contract management, and as you can see at the bottom, a large number of companies are involved in that. So what are the basic requirements for a secure audit web service? First of all, authorized writing with only append mode. It mustn't be possible to actually change anything that's in the audit log. Once it's in the audit, it stays there, and you can only append to it. You can't go back and rewind and delete or change it. The records are time-stamped so that you know when records were made. You must be able to store any digital content, because it's a general purpose service that anything can write to it. You must have secure communication with the audit service that's tamper resistant, so that if anybody tries to tamper with the information that's put in there, you'll know it. And so you need to have integrity of the data that's given to the audit service. You need to be able to store it in insecure media persistently and resiliently. At the moment, we don't have trusted computing platforms where we can store things and know that they're not going to be tampered with. We have to rely on normal disks, hard disks, etc. So what we need is tamper detection. We can't actually have tamper resistance. We can't resist tampering, because clearly a system manager or anybody who has access to a disk can delete anything and edit anything, can't it? So you can't, in general, provide tamper resistance. What you can provide is tamper detection, so that when you recover the file and read it in, you can find out if a record's been deleted, if it's been truncated, if anything's been inserted, or any modifications have been made. So that's all we can really go for in the design, is tamper detection. We need to have login efficiency. We've set ourselves a target of 500 records a second as the sort of speed that we need to have to give reasonable performance. We need to be able to support multiple simultaneous clients who are writing into the audit, so you can actually get records from multiple sources and have them in one audit log. And then authorized reading, so that the logs may only be allowed to be accessible by certain people, not by anybody. So this is the design of the audit web service. There's going to be an SSL connection over the internet with a web services server on top. It's going to be written in Java, so there'll be a Java API to it. This is the bones of the service that written in Java that actually produces the audit logs, writes them out to insecure storage in a secure way. There's going to be applications who can actually call it via the Java API on the same computer, so it doesn't have to be remotely accessed, or remote applications will be able to come in over the internet and access it over HTTP and SOAP. So as this diagram shows here, you may have multiple clients who want to write information into the audit log, and then you'll have one source writer that will collect all the information together. So I'll skip over this. This was a talk on what SSL is, but I'm sure everybody knows what SSL is. Now, what we wanted, as I said, we had a performance target, and the performance target was that we should be able to write at least 500 records a second to it. So we did some measurements, just using the standard PC of SOAP without SSL and SOAP with SSL, and we found that we could get down to 1.3 milliseconds for 1K. So that performance was okay. That was SOAP over SSL, so that would be acceptable. We then tried web services security, and we found that it took 520 milliseconds to write 1K. So it's basically a non-starter. So at the moment, using XML web services security is absolutely a non-starter for any sort of service you want any performance out. It's an order of magnitude slower than anything else. So we are forced into using SSL. And TCP with SSL performs a little bit slightly better than SOAP, but SOAP is acceptable. And that was the computer that it was running on. Okay, interactions between the source server and the client then. It's going to be based on SSL, and the client will send the messages to the source server. The source server will get the message, it will add a timestamp, it will add the encryption, the security to it, and then it will store it. So what I'm going to look at is the security that we're adding to the records. So first of all, a source server generates a new random secret key when starting a new file up. And that secret key is only known to the source server itself. And the source server also has a public-private key pair. So it encrypts this new secret with its public key, and it stores that as the first record of the new audit file. So the source is the only entity that's actually able to recover that using its private key. And the private key we're going to store in the trusted computing bases now, because most computers that are actually coming out, and in fact there's something like 2 million computers have already been issued with TCBs in them from IBM and Hewlett-Packard, etc. So the private decryption key will be held in the TCB of the source server so that nobody will be able to get access to it. Each record will have a secure hash appended to it, and this will guarantee that the record can't be tampered with. So the secret that's only known to the source server will be added into the record to create the secure hash, so that the source will be able to validate that the record is genuine. And then at the end of the file, we will do a digital signature, and that will be done with the digital signing key pair. And the public key of the digital signing key pair will be made available to anybody, so that means anybody can actually read in the audit file, they can check the digital signature at the end of the audit file, and they can know that the audit file is totally been not tampered with because of the digital signature at the end. Okay? But what happens if you fall over in the middle? What happens if the source server falls over in the middle? Or what happens if someone starts to tamper with the files? How do we know? Well, we're going to chain the files together so that the name and the details of the previous file will be stored into the beginning of the current file. And then the digital signature over that will prove that this was the previous file. It'll be linked into the next file via the hash of the previous file will be stored into the next file. So that if anyone tries to delete one out of a series of audit files, then you'll know that one's gone missing, because when you try and validate one file, you'll be missing the hash of the previous file, which is stored in the next file. So that should stop it. How do we stop truncation of a file from the end? Actually, there is no way well, you can know that the file hasn't been truncated at the end, but you can't actually stop it. So if you imagine the audit server falls over in the middle, so each record has got a secure hash. So we can check, source can check that each record has not been tampered with, but if it falls over in the middle, the attacker could actually delete the last 3 records, say, which actually indicated what he was doing, and then you've lost a record of what he's done. Did you follow that? We don't believe there is a way to protect against that other than creating multiple copies of the audit file. So that when you're creating the audit file, if you write it out to multiple locations, the attacker would have to actually hack multiple locations and delete the last few records off multiple locations. But we don't believe there is a way, if you've only got one copy of the audit file on the same computer that actually falls over, that you can't actually stop someone deleting records at the end. If someone thinks they've got a solution to that, please tell us, and we'll look at incorporating it into the design. But we don't believe that is possible. Okay, so we're going to have this TCB. The TCB will be able to tell us if something's been tampered with, but it won't be able to stop it. And what will be stored in the TCB will be the accumulated hash of the record of the file as we go along, so that if we do crash and we come back and we find that the hash of the part file equals the accumulated hash in the TCB, then we know it hasn't been tampered with. So we know it's a good solid file. But if it has been tampered with, then we won't know what has been deleted from it. There's no way of finding out how much has been deleted. Okay. But if we store it in several locations, then hopefully that's a way to stop someone actually tampering with it and be able to find out what tampering has taken place. Confidentiality. It may be that in some audit files you want to have it confidential so that not everybody can read it. There are 2 ways you can have confidentiality. One is to switch on confidentiality in source, and then source will generate a new random number and will encrypt the records with the new random number, and then it will encrypt that random number to the public keys of the authorized readers. And then the authorized readers will be able to use their private keys to decrypt the encryption key and then decrypt the record. That's one way. The other way is that the client that's writing records into source can itself encrypted information using its own secrets, give encrypted information to source, and then only it will be able to actually read them when it recovers the audit file. So there are two ways you can have confidentiality. One is that source will provide it for you. The other is that clients can give confidential records to source. What about private key loss? Okay, what happens if the private keys that source is using gets lost? Okay, well, it's going to have two key pairs. It's going to have a signing key pair and an encryption key pair. The encryption key pair should be backed up in a safe so that when it's generated, it will create as a PKCS12 output, and then that should be taken away and stored in a safe. So that if there's a serious catastrophic failure of the server and it loses all its keys, you can actually recover the private key at boot time by feeding in the PKCS12. The signing key pair doesn't need to be backed up, which means that no one can ever generate a proper audit record because they will never have the private key. The private key is generated by source, it's kept inside source, it's never exported from source. It doesn't matter if it crashes and gets lost, because when it comes back up, it will generate a new signing key pair. And on the outside, you can have multiple public key pairs from the source, and you can validate the signed files using whichever key pair was valid for that particular one. So we don't ever need to give the signing key out to anyone, which means that nobody can actually generate sign a source file on behalf of source. Okay, protection summary then. Each record is protected by a secure hash, and only source knows what that secure hash is, which means that nobody can actually generate a record because they don't know what the secret is, so they can't insert a record into source. Each record is chained together with a sequence number, so no one can pull any records out of the middle, because if they do, the sequence numbers won't work. The whole file is protected by a digital signature. As I said before, the only weakness now is if an attacker can crash source, he can then remove audit records from the end of the file without detection. But if we have this hash, accumulated hash stored in the TCB, then that will, at least we'll be able to detect that he's deleted records, but we won't be able to stop it happening. Okay, and he could delete whole log files, but by writing the log files to different locations and chaining them together, we can detect that as well. Okay, so we're going to use this new feature of TCB. This is the thing we're actually experimenting with at the moment. I don't have any practical results because this is something we're actually doing at the moment, is using this technology. The TCB will store the private signing key, it will store the private decryption key, and it will store the accumulated hash from the last audit file or the record written, so that it can actually, on recovery, it can actually check the length of the thing. Okay. So, as I say, all new IBM computers have it. In fact, those of you with new laptops, you have this feature in it already if you've got an IBM laptop. You don't know about it because you haven't got the software. But if you go to IBM's site, you can find that you can download software to start to access the TCB on your laptop. Okay? So my new laptop, from my new X40 laptop from IBM, has actually got the TCBs in it. And so there's something like 2 million of them in circulation now. Okay, how are we doing for time? We're okay. So this was just talking about the logs, the log record format. We wondered, is there a standard log record format that we could use rather than inventing our own log record format? We found that really there wasn't a standard. The only one we actually came across was the combined log record format, which is used by a lot of Apache servers, but that's really only designed for storing URLs that have access to Apache. So we have to define our own log record format. So this is the log record format that we've got, where you've got the sequence number, the log record type, which is for our own purposes, the timestamp of the log record, the length of the last log record, the length of the current record, the data that's been given by the client, and then a hash at the end, which is a secure hash for the whole record. The reason why we've got back pointers and forward pointers is it actually makes it quicker to go up and down through the file if you need to actually search backwards and forwards through it. There'll be different types of log records. Source random number will say that this is the secure random number that's been generated by source, which is encrypted to source public key. That's the one that's created for each file, and each file will have a new different random number there for creating the secure hash at the end of records. There'll be the symmetric encryption key, which is optional. That's if you want source to actually encrypt up the records and store them encrypted. There'll be the details of the last file for the chaining. There'll be the log data for holding client log records. There'll be accumulated hash, etc. So those are just different record types. Initializing source, you need to create two key pairs. you need to write both keys to the TCB, both private keys. If there's an external CA available, then you can get both certificates signed using PKCS10 format or CMP. Otherwise, create self-signed certificates. Export the public key of the signing key to file and the private decryption key to PKCS12 to be stored in a safe. Create a new secret key, write it to the audit file encrypted with the encryption key. Write new installation to log file, initialize the function with the secret key and write it to the TCB. So that's the initialization process. Restarting it after a crash or at the beginning of the day, we need to check the signature on the current file. If the signature on the current file is correct, it means that we close down normally and we can start all over again. If it isn't correct, it means that we crashed previously because we didn't have a chance to write the signature. So what we have to do now is we have to go through every record, validate every record, check all the check all the secure hashes, make sure that non-records have been tampered with. And when we get to the end of that, we can then put a signature on it, seal it, store it, and then we can start it all again with a new file. Okay? So that's quite a long startup process. Restarting source, if you're running it on a computer with no TCB, so you don't actually have your private keys there, then you're going to have to ask the manager, can you give me the PKCS12 file that you've had in the safe, which has got your decryption key in, and read that in, and then generate a new signing key pair for signing the next lot and get those certified by your CA. If you've got an external CA, prompt for the last audit file, and extract the accumulated hash from that, ready to put into the next one, storing the TCB. So that's restarting if you don't have a TCB. Probably that's all I want to say, actually. There's just more details about the design. Yeah? And does anybody have any questions about this? Yeah, good. Shall we wait for the
Or you could repeat the question.
Oh, I could. Yeah, okay. It's probably quicker, actually. I'll repeat the question.
To what extent can you rely on the timestamps?
The question is, to what extent can we rely on the timestamps? The answer is, to what extent can you rely on source? I mean, if you trust in source to actually store your data without tampering with it, then surely you can trust it to tell the time correctly.
Well, what steps does it take to ensure that the time hasn't been tampered?
The thing is, if someone can tamper with the time, and you're talking about them tampering with the system, then you're assuming they can tamper. So then they could tamper with audit records, maybe. I mean, basically, you know, I don't really buy into these secure time stamping functions. I think in most of the cases, it's a lot of unnecessary hot air. That's my own personal belief. I mean, you know, computers, you can pick up time signals, and they can automatically get time signals and pretty accurately. I can use timestamp protocol, or whatever, you know, NTP. I don't really think it's necessary. That's just my own personal feeling. Okay, Andrew.
Yeah. Just a thought which you've probably already had. I think you can constrain or you can limit the length of time during which an intruder can take stuff off the back by simply putting a heartbeat in and knowing that you generate a record every second. And then that means that you can only delete back at most 0.99 seconds.
Right, but there's a timestamp on the records anyway.
Yeah, what I was thinking was if you know you're generating a record every so often, then I think you can...
You're saying if there isn't a heartbeat... what you're saying is, if no audit data is actually coming in, then it may be an hour since there's something written there, so you don't know whether someone's stolen an hour's worth of audit records or whether they haven't. So what you do is you actually purposely write null records every second, and then you can actually see whether someone's actually purposely deleted or not. That's a good point, actually. So that is something we haven't got in the design. It's something we should put in. So thank you very much for that.
Okay.
Okay. Yeah.
No, it's just putting together what I have been talking at the beginning, because it was one of the common services, this audit service and this. Which is the state of the project right now, and could be used, because I haven't seen IBM, Microsoft, and some names that maybe this is patented or somehow.
Okay, the actual code will be BSD open source, so it will be there for anybody to use when it's released. Where we're at the moment is we're building the various bits and we're doing the various performance checking on them. As you can see, I've given the results of what we've done because we want to make sure we can get this performance threshold. What we're doing now is we're checking the performance of the TCBs because they may perform badly. We don't, because everything, the TCBs, they all work via asymmetric encryption. So there's a certain time there. So at the moment we don't know, and there's also problems with open source interfaces to TCBs and Java interfaces to them. At the moment they're not yet properly fully standardized and available. There are commercial stuff you can buy, but so there are some issues to do with the use of TCBs. But it's in the design because we know that maybe even if we can't use them today, we can just stick them in a file for now, an encrypted file with a password. But if it's in the design, 1 or 2 years down the line, everybody will be using them. So we can migrate over to it.
So when can we play with this?
when can you play with it? I would say it's going to be the autumn. It's going to be the autumn. Yeah. Okay. Yeah.
I think it fits. Well.
Hi, I've got a question about the throughput, the logging throughput, because you even showed the value of 20 milliseconds per record. And what's the overhead of this hashing function on logging?
Oh, it's actually minuscule. It's the speed of writing to disk and of doing the hashing is absolutely minuscule. I mean, it's like 0.1 of a millisecond or something. I mean, it's the main performance bottleneck is the transport over SSL and TCP. That's the slowest bit. That's the bit we've got to get the fastest of the lot. Clearly, if you call it via the Java interface and you get rid of that, you'll have a much higher throughput. But what we want, yeah.
Thanks.
Okay. Andrew. The question is the poor performance of web services security, is it an implementation issue or a fundamental part of the design of web services security? My understanding is it's a significant bit is the fundamental to the design because of the way it's character encoded, and you have to do this normalization of characters and they don't actually call it normalization, but it's equivalent to that. And to make sure that spaces and carriage returns and all this other stuff are not there, and that all the characters are exactly this what you think they should be, and yeah. So that's the main problem. Canonicalization is the term. Yeah, it's the canonicalization.
Just a note, we have been talking about in the GEANT AAA. We were wondering whether used the web service security. And we have gone for TLS channels just because all this canonicalization is madness, really.
Yeah.
It's something that's...
Yeah. So it probably isn't solvable by doing a better implementation. I think they'd have to change the design.
Mine is a simpler question. Do you plan to have a syslog interface for these? It could be very useful for normal system logging.
Yeah, we haven't thought that far because, as in the general rationale for providing it, it was meant to be for, as I said, for the VO and the authorization infrastructure. But given that there's a Java API, it should be trivial to build a syslog interface to that to call the Java. Yeah. Oh, right, okay. So it's now my pleasure to close the session. that was two-faced commit. Okay. So thank you all for coming, and we've managed to finish on time and have an extra session. So that was good. Thank you.